Hi there, this is Irv Shapiro of the Dr. Vax channel, and today we're going to cover what might be the most complex topic I've ever covered. We're going to talk about installing Marlin 2.0 onto your 3D printer. And we're going to look specifically at two examples, the ANET ET4 and 5 and the Ender 3 version 2. So stay tuned and let's learn something together. Now, there are advantages and disadvantages to both these printers. However, both of them share a disadvantage, and that is that the firmware that ships from the manufacturer may not have all the features you want. I'll give you a quick example. On the Ender 3 version 2, they have a graphical display, and in this graphical display, there's no location for messages. On the ANET 3D printer, the proprietary firmware that ships with the printers doesn't really have good capabilities for fine-tuning the printer characteristics. Now, the latest version of firmware from ANET is starting to make improvements in that direction, but they're not perfect. So in both these cases, in the case of the Creality printer and the ANET printers, it'd be nice to be able to load your own firmware. The most recent version of firmware available for a wide range of printers that is also widely used is called Marlin. And today, we're going to look at building Marlin for your particular printer. Okay, now before I get started with the meat of the video, there are two important things. The first is the best way to support me so I can produce more videos is to subscribe. Now, you're probably aware that subscribing to a channel on YouTube is completely free. All it does is send a message to YouTube that people are interested in my videos, and that sort of feeds on itself because then YouTube will recommend my videos to more people, and it's all good. So if you could subscribe to the channel, click on the bell to be notified about future videos, that's great. The second piece of bookkeeping, so to speak, that I need to do is I need to say thank you. Let's look at this slide together. These are some of the people whose videos I watch, where I learned about some of the pieces that I'm combining together in order to make this video. Specifically, I need to call out David Teran, T-E-R-A-N, because David has ported a version of Marlin specifically to the control board used by the Ender ET4, and I'm going to show you some examples of that today. Now, what is the advantage of Marlin 2 versus Marlin 1? Well, this is a 32-bit control board for the ANET ET4 5 line of printers. This is an 8-bit control board from a Creality Ender 3. Now, this board is clearly bigger, but that's not good or bad. What is good about this board is because it uses a 32-bit microprocessor, it has more memory space. When you're using an 8-bit board, such as this board, because of limited memory, you have to sort of pick and choose what features you want to use. With the 32-bit board, you'll have the ability to include many more features in your printer. Where does Marlin fit? Now, I know it's stored in memory on this control board, but where does it fit? So let's look at this picture together. The 3D printing architecture most of us are used to really starts with a three-dimensional model produced in a program like FreeCAD, Tinkercad, or Blender, and very often that produces an STL file. There are other supported formats. That's the most common format. But those STL files are not produced layer by layer. They're three-dimensional objects made up of triangles that are in a mesh. So we need to convert those into instructions so we can print layer by layer. That's done by a slicer. Cura, Prusa Slicer, Slimplify 3D, or many others. That produces G-code. The G-code is then sent to the printer control board. either by putting it on an SD card, a USB card, or plugging something into the printer, the program that interprets that G code and then sends electrical signals to your stepper motors, to your bed heater, to your hot end heater, to your fans, that program is the firmware in your 3D printing control board. And the firmware we're talking about today is called Marlin, specifically Marlin 2.0, which is optimized for 32-bit boards. How does your board know how to run that program? Well, when you turn on your printer, your board looks for a program at a specific memory location, and it starts running that program. The problem is that if you want to update that program, unless you have a component called a bootloader, which I'll explain in a moment, to upgrade the memory on this chip, you have to use a special microprocessor programmer. And basically what you do is you connect pins on this programmer to pins on this board, and then you use a program to update the code, the firmware on this board. Well, these boards are not exposed. If I look behind me at this Ender ET4, I don't see this board anywhere. I have to take the bottom cover off. I have to unscrew. On the Ender, there are a lot of screws. It's very well made to get to this board. So it's not something I want to do all the time. Well, one of the advantages of using a system like the Marlin 2.0 system is it's constantly updated. So I want to be able to upgrade my firmware often. How do I do that? I use a bootloader. Let's look at this next picture together. You'll see here there's an arrow pointed at 0000. That doesn't necessarily have to be the starting address for your program. I'm using that as an example. If instead of loading the firmware, the control program for the board in that address, I load a special program called a bootloader in that address, I have more flexibility. What does the bootloader do? Well, the bootloader looks to see whether there's a copy of new firmware on your SD card, or whether there's a special program trying to talk to the USB port that is saying, I have new firmware. If it finds that, it reads in that new firmware, and if we look back at the picture, it loads it at an upper memory address. I pick 1000 hex as an example here. And then it runs that. Now, the next time you turn on your printer, the bootloader looks to see if there's new firmware. If there isn't, it just goes to that upper address and runs the program. So with a bootloader on your program, and the Ender 3 version 2 has an excellent bootloader built in, you can upgrade your firmware anytime you want. The ANET ET4 does not have a bootloader built in, so we're going to load one on our ET4, ET5, in our case, our ET5. Now, how does the bootloader know if it's a new version of the firmware? It depends on the bootloader. In the case of the Ender bootloader, look, it stores the name of the last firmware program it loaded. If the name on the SD card is the same name, it doesn't load it again. If the name is a new name, it loads it. So if you want to upgrade the firmware on your Ender 3 version 2, you have to give your firmware a new name. In the case of the ET4, the bootloader renames the file so that it knows not to load it the next time, and anytime it sees a new file with the right extension, it automatically loads it. In both cases, you should only have a single firmware file with the proper extension on the SD card. And in both cases, the SD card should be formatted in FAT32 format and should be 16 gigabytes or smaller. Now, where do we find this Marlin program we're going to load into our bootloader? Well, we could go to marlinfirmware.org and we could download the current source code from there, or we could go right to the GitHub repository. I'm going to show you how to do that in a minute. Now, in a minute, you're going to see that building Marlin from source code takes a number of steps. The hardest part is just getting all the software installed on your computer to do that build. If you don't want to do all those steps, there are alternatives. If you're using a Creality 3D printer, the auto build service for $10 a year has firmware for a wide range of Creality 3D printers. And it's updated nightly in most cases. So you can just download the file, and as an example, if you're on an Ender 3 version 2, take the bin file, make sure it has a new name, put it on the SD card, and load it. If you're using an Ender 3 version 2 with a BL Touch, I think the folks at Smith 3D have an excellent build of Marlin with some extra features that make it easier to use your BL Touch. And I'll list all of these URLs in the description below. And finally, there are going to be a fair number of configuration steps. Tim over at TH3D has a version of the Marlin firmware called Unified Firmware, where he's really made it much, much easier to configure for specific printers. And I'll list the address for the Unified Firmware in the description below. Okay, now, let's assume we're going to build it ourselves. What's the first thing we need? The first thing we need is an interactive development environment. And we're going to use Visual Studio Code. So go to Google, type in Visual Studio Code. It'll take you to the Microsoft site and install this software. I'm not going to click through installing it for you. That's not very complex. The next thing we're going to need is a way to build the code for a microprocessor, not for a regular computer. So to build it for a microprocessor, we're going to use an add-on, an extension to Visual Studio Code that is called platformio. And I'll show you how to install that. Now, platformio knows how to build code for many microprocessors, so it's a little bit tricky to configure. You edit a platformio.ini file to do that. If you're specifically building for Marlin and you don't know what chip is on your board, well, there's an add-in, an extension for Visual Studio Code called Auto Build Marlin that will help you with that. Today, we're not going to use Auto Build Marlin because the platformio.ini file that we need for our Ender ET4 or 5 that we're going to build for today has already been updated by David. So we're going to use his platform.ini file. But if you're building for one of the Creality printers or one of the other many, many printers available as standard configurations on Marlin, you're going to want to use Auto Build Marlin and just follow the instructions on the screen. It will automatically populate the platformio configuration for you. Now we're going to need one more thing in our case because remember, our board doesn't have a bootloader. So we're going to need to use the STlink programming utility that you see here on the screen in order to load the bootloader into this device. Now let's look at the steps to build the code. Number one, we have to select which Marlin source code we want. We have to install Visual Studio Code. We have to install platformio. I'll show you that. We optionally install Auto Build Marlin. Then we edit the configuration files that define how Marlin interacts with our hardware. We compile it, we load it onto our computer. If it's an Ender 3 version 2, we load the .bin file with a unique name on the SD card. If we're using the OpenBLT bootloader, which is what we're going to use here, we actually load the SREC file, not the bin file. And if you have a different configuration than that, you are going to need to use a programmer, and you'll select the file format that's appropriate for your programmer. Let's go hands-on now and take a look at this together. Okay, I've pointed my browser at the standard GitHub Marlin repository. It's github.com, Marlin firmware / Marlin. And if I want to use the very latest build, all I need to do is go over here to this code icon and say download zip. Now, GitHub is an environment, if you're new to programming, that allows programmers to collaborate. We're not going to use the collaborative capability of checking in and checking out code. We're just going to download the zip file and unzip it. Now, there's one other file that you're going to want to get in order to get support for your printer. If you go over here to configs, you'll see there's a URL here for an archive of configurations. And as you can see on the screen here, there are a ton of configurations. So you download that file, you unzip it. Then you go to the printer that you're going to be building for, could be the Ender 3 version 2. You copy the configuration files from that directory, and you're going to copy them into the proper place in Marlin. I'll show you where that is in just a moment. Now, in our case, we're going to do something a little different. We're going to go to what's called a fork of Marlin. So a fork is where you take a GitHub repository, you make a copy of it, and you modify it for a special case. In this case, David has modified the standard Marlin build for the ET4 5. And so we're not going to start with the standard Marlin build. Instead, we're going to start with his build. We're going to go over here to code. We're going to download the zip file, and then we're going to open that file in Visual Studio Code. So let's start up Visual Studio Code and see what the next step is. Okay, things you'll notice are a little bit slow. It's not because these tools are slow. I'm using a very, very inexpensive, literally a $350 Windows machine I bought a couple years ago that's underpowered, does not have enough memory. The reason I'm using it is I normally do my work on a Mac, but I thought it would be beneficial to everyone to show you how to do this on a Windows machine also. The tools run in both environments, with the exception of the programming tool for STlink. The version of the STlink programming tool for a Mac is very complex to configure. It requires Java, a number of things, whereas the programming tool for the STlink programmer for Windows is very easy to use. So that's another reason I'm using Windows today. So the first thing we're going to do is go over here to this little set of squares, and if you mouse over that, you'll see it says extensions. I'm going to click on that, and I'm going to type up here platformio, and you'll see that it's listed as one of the extensions. Now, platformio does not have the word install next to it because I've already installed it. If you're just using Visual Studio Code, I want you to click on install and install platformio. Now, in my case on this slow machine, it actually took quite a bit of time, like 5, 6, 7 minutes. So it wasn't snap. When I installed it on my iMac, which is a fairly fast machine, it installed right away. Now, in addition, if you're going to be using one of the standard builds in the configuration files, you also want to type in auto space build space Marlin and install that option. I'm not going to be using that, so I'm not going to install that particular option. Once you're done installing platformio and auto build Marlin, if you're going to need it, you go to open folder. So I'm going to select that folder, and we'll see it opens up. It's going to take a moment to open up because platformio is going to notice that there's a platformio.ini file in that directory, and it's going to run in the background and get all set up. So let's wait a minute for this to all finish processing. And if we look down here on the bottom, see that spinning wheel? We'll see that platformio is in the process of rebuilding its index to do its magic. So we need to wait a second for that to complete. Okay, you'll see on the screen now that platformio has loaded. So if I go to this little arrow here and I open up the directory, you'll see one of the directories in here is called Marlin. That's where we're going to do our work. You'll see there is another directory called config, and underneath you'll see user configs, and those are some extra configurations that David has collected from the community. Your machine might have a whole bunch of printers in there, depending on the version of Marlin that you're loading, or it might have a link to that set of other configurations on the web. Now, you do not edit the configurations in the config folder. You edit them in the Marlin directory. So if we go down to the Marlin directory, you'll see there are two primary files we're really going to need to use all the time. The first is called configuration.h, and the second is configurationadvanced.h. Most of your work is going to be done in those two files. In our case, David Taram has created another file called easyconfig.h that will use C macros in order to make it easier to get the setup right for the various versions of ANET printers that he's supporting. And then finally, you'll notice there's a file here called platformio.ini. Let me open that for a minute. And you'll see at the top, it's providing information that David has already filled in about the configuration that we're going to use. Now, there is one thing we have to change in platformio to make sure it builds our code for the upper address range, because that's where Open Bootloader is going to put it. So I'm going to hit Control F and type in ET4 and find the locations where ET4 is listed in the configuration file. And we're going to go down right over here. Now, you'll see there's already a comment that says Dr. Vax there. This line was commented out when I first came into this file. So this line says that there is a bootloader offset. This is where the bootloader is going to put the code. So this has to be set to 10,000 hex, OX 10000. So you want to remove the comment there and save this file. First step. Now the next thing we're going to do is we're going to open up a file called easyconfig and go to the top of this file. And this is a file that was created by David with a series of macros. And there are a set of instructions in here. A macro in a .h file is basically a command that starts with a pound sign. And you'll see here that we have to define right over here which printer we're going to be using. And it gives you the possibilities up here. Ours is defined as ET5. And I'm going to actually add a comment here. I'll show you why in a minute. Dr. Vax, ET5. So I can find that later. And in C, either a double slash or a slash asterisk is used to indicate a comment. So we've defined which printer we're going to use. The rest of this file is all optional. We're going to make one other change, and down here, I'm going to actually give my version of the boot a unique name, so we'll see when we boot the machine, that name's going to come up. So let's save this. Now the next file I have to edit is config.h. And let's start at the top of this file. And you'll see here, right over here, it's about line 42, define ET easy config is defined. Now that's going to be the linkage that tells the Marlin build to use David's special file. So that has to be defined. And then there are a couple other changes I made in this configuration. So just to make it easier to find those, I'm going to search for Dr. Vax. And you can see that the first thing I did is I put in my own PID values. Now, what is PID? The PID algorithm is an algorithm for setting temperatures of a heated element. So let's say you want to heat the hot end on your printer. You turn the power on to the heater. It goes up to that temperature, and you turn the power off, it keeps going up. It's like using an electric stove. It's already hot. Then it cools down below the level you want. It gets a little too low. You turn the power on, goes back up again. And you'd start flopping back and forth. Well, the PID algorithm is a way to fine-tune those movements, to know how early to turn it off, how long to leave it running. These happen to be the parameters I got off my ET5. You will not be filling these in to start with. You'll just use what's already in the file. But the first thing you need to do after you burn the new firmware into your printer, you load the new Marlin firmware, is to do PID tuning. Let's see what's next. This one is very important. The ABL sensor is over here. The nozzle is over here if we look at the printer, and I'll show you a picture of that on the screen. That distance is an offset. Now this is like a number line. If that distance is to the left, it's a negative number. If it's to the right, it's a positive number. If it's to the front, it's a negative number. If it's to the back, it's a positive number. So this is the position of my nozzle. You must fill this in. If you don't, the auto bed leveling will not work correctly. But more importantly, when the printer moves the nozzle to the extreme of the bed, the sensor will actually be off the bed, and it may cause the nozzle to crash into the bed. The next item is that there's a feature in Marlin where you can move to the corners for manual bed leveling. But remember, the sensor's over here, the nozzle's over here. If that feature attempts to put the nozzle at the end of the bed, the sensor will be off the bed. And then the next thing you'll see here is that I've set the language to English, because in David's default build that I downloaded, it was set to Spanish. So this sets the language to English. So let me go ahead and save this file. And now let's look at config-advanced.h. And you'll see there's one entry I've made in this file. And that is the entry to say that I want to include the auto bed leveling Z offset wizard in my build. And I'm going to demonstrate that at the end of the video. So that's a very important addition to configuration-advanced.h. So let's go ahead and save that. Now, this slide deck with all these instructions will be made available on forum.drvax.com. Forum.drvax.com is the user community for people watching Dr. Vax videos. Okay, I've made those changes. Now I can go here to this check mark down here, and I can say I'm ready to build this code. And as I said, this is a very slow machine, so this is going to take a little time. I'm going to fast forward past that. Okay, now we see that the build has succeeded. The platformio system is reporting to us the amount of memory it will use on in our microprocessor environment. And we are ready to load this into the printer. Now remember, there are two different scenarios. In the case of the Ender 3 version 2, you go to the .pio directory and you find firmware.bin. Now, because the PIO directory has a dot in front of it, you may not be able to see it from your file explorer. So if you right-click on that file, you have an option to reveal it in your operating system directory system. And we just need to now copy this file to an SD card. Now remember, the file name for an Ender 3 has to change. So we'd have to change it, copy it, put it in the machine, turn it on. Now in the case of the ANET ET4, ET5, it's a little different. In that case, first of all, we use the file called firmware.srec, which we can see is a hex encoded file. We also copy that to an SD card. In both cases, the SD card has to be formatted as FAT32, and the recommendation is generally they never be bigger than 16 gigabytes. 8 gig cards are even better. Now, how do we get a bootloader onto our ANET machine? Well, I'm going to show you that now. The first step is to connect our STlink to our board. And I'll show you this picture on the screen which shows you the pinouts. Basically, you have to connect the ground, the clock, and the data pin. Now, in the case of the STlink, the data pin, I believe, is called IO. Yes, it's called the IO pin. So IO on the STlink is the same as data on the ANET board. So you have to connect those three connections. Now, it's not going to be as easy as this because this is going to be inside your printer. So you have to turn your printer on its side, you have to take the back off, you have to make these connections. Be careful, because the pins on the opposite end of the STlink device are power pins. You do not want to connect those. You could damage your board or your STlink if you do that. Then plug this into a USB port on your computer. And yes, you can use an extension cable, which I needed to use, and carefully turn on your printer. Now we need to run the STlink utility on our machine. And let me show you that. So here's a picture of the STlink utility before we've connected it. Now we need to go to the plug connector. It's the third icon on the top, and click on that. And when we click on Connect to Target, it should look like this. This will show you what the current program loaded on your board looks like. Next, we have to replace that program with a new program. To do that, we go up to Target, and we select the option called Program. And that's going to prompt us for a file to load. We want to load the OpenBLT file. Now the file we're going to load is the same for the Ender 4 and the Ender 5. It's called openblt.bin, and it has ET4 in the name. Now click on that file name and click on Open. And then all we have to do is click on Start, and this will transfer the bootloader from our computer to our ANET board. Now, if you want to, you can carefully power cycle your machine after you disconnect your programmer, and you should see an OpenBLT logo on the screen. Now, the machine's going to be on its side. You have to look at it on the side, but you should see an error message that it can't find a firmware program to load. That's because we haven't put the SD card back into the machine yet. So now put the SD card back into the machine, power cycle the machine. At this point, I've actually closed it up and it's right side up, and you should see what I'm going to show you on this next slide. Now, image number 1 is the OpenBLT flash screen. It's showing that it found a program on the SD card and it's loading it. Image number 2 is the Marlin logo, and you'll see it's pointing to David's repository. And image number 3, you'll see has ANET ET4 Dr. Vax video. That's the description we put into our build, showing we're running the version we expect. Now, you're not ready to start using the printer right away. If you do start using the printer right away, without these next calibration steps, you can expect to see a screen that looks like this. That's because we haven't run the PID calibration, the calibration of our temperature subsystem that allows us to heat up the hot end and the build plate appropriately without overrunning the temperatures. So next, we have to connect a terminal of some type to our printer on the USB port, and I'm going to show you how to use Matter Control to do that. The first thing you want to do is you're going to add a printer. It'll walk you through that process when you first get started. I've added a ET4, ET5. For our purposes, it doesn't matter. So you see the 3 dots here on the right. You have to click on those and make sure Show Terminal is turned on. Then we can click on Terminal here. And now I've connected my computer via a USB port. I'm going to power on my printer. And you'll notice it immediately connected. I'm going to type in a command to run a PID auto calibration on extruder 0, which is the first one, to a temperature of 200. And just to make it faster for our test purposes, I'm going to run it just 2 times. Hit a return. And you'll see at this point, PID Auto Tune will be running. Now I'm going to take these values that come back. I'm going to issue an M301 command with the values that are reported back, replacing the variables on the screen with the variables that are reported. Then I'm going to do the same thing for the bed by doing an M303 E-1. On this printer, E-1 is how you say the bed. Then when I'm all done, I'm going to issue an M500 that will save the current settings in the printer. Okay, now we're going to look at calibrating the ABL system. Now, before you get started, if you haven't already done this, watch the first video I made on the ET5. In the middle section of the video, it shows you how to ensure that this x-axis is leveled properly and that the four corners are working properly. We're going to double check now, just to make sure everything's working, that the bed sensor, that the auto bed leveling sensor is properly sensing the bed. So I'm going to take and I'm going to select motion, move axis, and I'm going to turn soft end stops off because I'm not auto homing first. If I auto home, it will find the bottom position. But if I don't, it thinks wherever I turn the printer on might be the bottom position. So I need to turn that off. So that's off. I'm going to select Move Z and move the smallest amount possible. And I'm going to start moving this down. Now my goal here is to move it down till this paper is just tight underneath the printhead. So I'm actually going to fold this Post-it note over to give me something to grab it by. Okay, it's getting closer. There we go. Now I'm going to take a small screwdriver. I'm going to adjust the sensor. So I'm going to turn it to the right until the red light comes on. Then I'm going to back it off, turn it a little bit more till the red light comes on, back it off until I get it just to the point where the red light is just on. Okay, that is my new home position. Now, if I do an auto home at this point, it's going to bring the hot end down until that sensor senses the bed. So let's go here, motion, auto home, and we'll see it go up. It's going to check the x-axis first, the z-axis. Now it's going to home until the sensor senses the bed. And you'll see that's perfect. So that initial calibration is very, very important to make sure your head will not slam into this device. Now, if I want to, I can go to the auto bed leveling system, motion, second screen, bed leveling, and I can say level corners. So that's about perfect there. I can go to the next corner. And that's a little tight, so I'm going to lower that a little bit. Okay. Now that that's done, I can go back to the home position, and I'm going to use the Z offset wizard that I added in the configuration. So that's under Configuration, Advanced Settings, Probe Offsets, Z Probe Wizard. This is going to move the printhead to the home position in the center and give us an ability to adjust the Z offset. That's the offset from the sensor to the bed. So I'm going to put this under here, and it actually feels just about perfect. But let's assume it wasn't. I would select Move and the smallest value, and then I can move it up or down. Down will make it closer. That's a little too close. Up will make, that's about right. And then when I'm done, I hit the check button. I hit the right arrow, done, and it's telling me it had to add a Z offset of 0.15. Now it's very important, at this point, I go back to Configure, Store to save the location. So I can go back here and go to Configure. Okay, folks, We're all done here. We have shown you how to configure and build Marlin. We've told you where you can find pre-built versions. We've talked about how to do it for an Ender 3 version 2 and for an ANET ET4 or 5. We've showed you how to set up the ABL system on the ET4 and 5. I hope you learned a lot. I know there's a lot of material in this video. Some of it I covered quickly, but if you learned a lot, give me a thumbs up, subscribe to the channel, share this channel with everyone you know. Go to forum.drvax.com to discuss it. Have a great day, and let's continue to learn things together.